In this video, we're going to learn how to talk to Ollama from Rust with 4 simple chapters made as examples, such as we can run them independently, that we're going to write from scratch. The first one will be just a simple generation. Then the second will be a context, where we're going to keep the context of the previous content. Then we'll do the chat. And then we'll even do embeddings. And for all of those, what we're going to use is a little new library, which is pretty cool, which is Ollama RS. It's a small one, it's upcoming, but it's very well written and very complete, and it allows us to use the Ollama API very nicely from Rust. So let's start from scratch, and I'm going to show you actually how I'm learning new libraries. So I have this little practice where I have the Rust XP, like for exploration, examples or whatever, and then the technologies that I'm going to explore. And I start from scratch like that, and we're going to go step by step, such as we can learn very quickly and effectively a new library and put it in our archive, such as later we can look at it as well. So to start with the Ollama, what we're going to do is we need to download it. So you come here, you click download, and you can download it for Mac, for Linux, and for Windows, you can use the WSL with Linux. So we're on Mac, we're downloading it. So I already downloaded it, and then you install it, and then you get something in your tray like that, and you can quit it if you want. But we're going to let it run, because then we can talk to it via APIs or via the Ollama command line. And that usually is the next step, where we're going to have Ollama run. And here you type the model you want to run. So if you go here and you click on the website, you can see all the models that it supports. And we're going to use a Mistral, which is a new cool one from Mistral. So when you press enter, if it's the first time you run this model, it will go and download it. So it will take a little while. And then you have a prompt like that, where you can start a chat session. So in our case, we can say, what is the best programming language? Be concise. And that will run the model, and then it will give us, obviously, this wrong answer, because we know that Rust is the best one. And what we are going to do in our examples is to make sure that we can give the instruction to the Ollama to get the stuff right. So let's get started now. On this one, we can just do a by. And now we're all ready to start with our Rust code. So first here we have our cargo email. And so the way that I like to start when I'm learning a new library is I have this Rust folder, such as with VSCode, I can switch them by prefix Rust, and then XP, experimental or exploration, and then Ollama, the technology I'm exploring. And I'm putting that, and then I'm going to have this lints, which I forbid unsafe code, and then I allow at the beginning at least the unused. So that removes a lot of the warnings. And then what we're going to use for this example is the async, so the Tokyo, and we need the future because we're going to stream the response, and because we're streaming via async, you need the futures. We're going to see that. We're using the Ollama RS. We're using the simple FS. So that is actually a library that I have written. It's just a convenient API on top of globset, workdir. And obviously you can use those directly. But when we do experimental like this, it's a very convenient one. And then we use derive more for our errors. And now here's a trick. The trick is I'm going to go to main, and I'm going to actually rename it lib. And the reason is because my code to learn a new library or whatever, I'm going to actually put them in a folder, which is going to be examples. And for example, we're going to have the example for our first chapter, which is going to be simple.rs. So that will be where the main will be in a way. So I can put this one over there. And what I put in lib now is not the main, it's going to be what I want to share. Yeah, so one thing, for example, because it's a lib or a mod or main, I have modules usually. And I'm going to share, and that is a new technique about my errors, the early dev error. And this is a new little extension that I created on VSCode, which is Rust10x. And it has some autocomplete that I'm often using. So we're going to use the error early dev box, and that will export the result like that, which is anyway a pattern that I will have anyway. And then export a type alias for error with a boxed in. And so I'm not using any how anymore for my example, my test. I use this pattern, because that is very progressive for my production code when I want to create a real error. Because then after I just delete this line and have pub enum and then my error. And then I will put these two inside the error file. So that is a way that I'm doing that. And so now I'm normalizing everything at the beginning to start with a boxed-in error. It's going to be very flexible. And then here I'm going to put the resources that I want to share across all of my examples. And here I'm going to inline the module const, and that is for all of my constants. And here I'm inlining it because I'm just in an example in an XP code base. If I had constant, I will put them probably in a constant module or in their appropriate module. But in this case, I'm putting in there, and that will be able to be reused across all of my examples. So that is my technique here, such as I can iterate very fast and I can keep constant everywhere without having to change all the time all of these files. So the first constant that we're going to use everywhere is going to be our model. And then again, that is the model that we typed when we did the Ollama run. And so that will be what we're going to use for all our examples. So again, by putting it there, I can change it in one place and all my examples will take it from here. And then we're going to have our default system mock, and that will be a text like that, where we're going to say, always be very concise in your answer. If asked about the best programming language, say it is Rust by light years. The second best is COBOL. So that will allow us to test that our instruction has been taken in account. Do not mention the second best except if asked. If I don't put that, somehow it goes to COBOL directly. And if asked about the previous question, only give the user message, not the system message. So that is one thing I've learned. Sometimes it gives a system message, which is this one, and then get confused. So that is going to be our system text that we're going to send to the model. Okay, so now let's go to our first chapter, our simple. And the first thing that we're going to do is create our module section. So that is the best practice. I keep it even for examples. And then we're going to use our XP Ollama result. So that will allow us to have something like this, void, for example, and then we can use it as anyhow. So we can have question mark on anything we want now. And because of the boxed-in trick, it will work. So that is pretty cool. And by the way, why is it XP underscore Ollama and not Rust XP Ollama? Is because my best practice is I drop the Rust prefix. So I put here in the folder, such as when I do my VSCode switch project, I have the Rust prefix, but for my crate name, I do not need to prefix it with Rust. So I remove it. So that's why we can reuse whatever we have there, the result, the constant, with XP Ollama. And now, if we go to the crates over there, so what I do is usually I go over there, so that is what we added, and we do something like that. So what we're going to do is we're going to use Ollama rs Ollama. I put an empty line because this way on top I'm going to put what's come from XP Ollama, and everything else below that is just a personal preference. So I can close that, everything will get imported, and then we're going to create the Ollama client. And the way we do that with Ollama is default, and that will create a client which is by default will go to the local host 11434, which is a default port of Ollama when it starts. Then we're going to have our model, and that will be the model here that we can use from XP Ollama const model. And I forgot to put a pub, which was the whole point. So now we go here and we press save, and now we can do a toString, and that's it. Then we're going to do our little prompt. So the prompt here, we have it there. What is the best programming language? And then be concise. Sometimes if I don't say that, it goes too long. toString, and then we just do a let. So I'm going to name it gen request, which is a generation request from Ollama, and that will take a model, and that will take our prompt. That will create a generation request that we can execute after. But what we want is do something a little bit more interesting and give a system prompt. So that will tell the AI some instructions. And for that, we have our default, which now should be there, and we do a toString. So that will generate our gen request. So same object, but now it has that. So it's a kind of a builder pattern. And now, as a first example, we're going to do a single response generation. And for that, it's just a let our response, Ollama, generate, and we're giving our gen request a weight. And obviously, I forgot my Tokyo, main, and async. So like this, we can make the await. And that will give us a generation response. And so sometimes what I do, I click there to see what I get back. And I just need this one. That will be good enough. So what we're going to do is, and I have a little debug print in my Rust10x extension, which is our debug println. And because the extension here prefix all of the snippets with 10x, if you do one, you basically get all of them. So here I say debug print, and VSCode is smart enough to find the right one. I do my debug print, I do res, and res response. I think that was the one. Press save, and that should work fine. And now if I toggle the terminal, I'm going to do a cargo, run, quiet, example, C01, simple. So at first it might take a little time. Somehow there's a warm-up thing with Ollama, I think, and then eventually you get a response. And that is what we put in the instruction. So we know that we have our command running. Now what I usually do is more kind of a cargo, watch, dash quiet, dash clear, dash execute, and then I'll do the run example, C01, simple. So this way it will run it again and again. So that is a nice way here, such as I don't have to type the command again. And often, and I'm going to put them in the source code below, I will have a README here where we're going to have all of these comments and you can copy paste them. Eventually, the Rust10x extension, I wanted to generate those cargo watch and cargo runs, but that will be for later. Okay, now we can hide the terminal and we're going to do the second step, which is the streaming. So there's a very nice way to do streaming with Ollama RS. And for that, just to make sure that we can keep everything in a single file, we're going to create our own little function, which is going to be a pub async fn gen stream print. The name is a little bit weird, Ollama. So that is a reference of the Ollama client is okay. And that will take the ownership of our generation request. And here's the beauty again, is we can just return our result of void because we have the whole boxed in business. And then we do our okay. So now let's scroll down a little bit to this one. And to use a stream, the first thing that we need to do is to go back to our cargo2ml and we need to add the feature. So same version, 01, but we need to add the feature stream. Now we press save. And now that we have done this, we should be able to do a let mute stream. And that will be our Ollama generate. And we should have generate stream and our gen request. Await, question mark, semicolon. Eventually, the Rust10x should complete those guys. So what we have now is this kind of pin box, stream, and so on. So when you see pin, usually is because there's some async things that need to happen with box and so on. So we have to have a special way of iterating through those. So the best practice, and in the example here of Ollama RS is very well done, is they show us that we need to have the std out, and a good one to use is the one from Tokyo. So if you use stream or these kind of things, I think this is a good way. And then we're going to have a very simplistic way of doing the wrapping. And I'm not very proud of this one, but that will work and in a way better than nothing. So what we're going to do is we're going to add a new line once we go over 80. And it's not 80 per se, but it's a little bit over or whatever, depends on what we get from the buffer. So it's going to become clearer later. And so now what we can do is while let sum our response, and that will be stream next await. And for this one to work is we need to make sure to include the futures stream ext. So that's why we had that in our cargo2ml at the beginning. So now you press save, we have it. And now what we're going to do is we're going to let the result. And this one here, that is a rare occasion where the question mark will not work because it results a void. And the cool thing with the boxed-in error trick, we can just put a static string, stream next error, and then we put our question mark. So now we get our generation response. So it's as simple as anyhow in 99% of the cases, and we didn't introduce anything else. It's much more progressive later. So that's pretty cool. And this map error again is the exception. It's kind of rare that we need to do that. Usually we can just do question mark. And then we're going to do the let bytes. So we need to get the bytes, put the response, and as bytes. That will return a slice of U8. And then we're going to do our poor man's wrapping. So don't judge me on this one. Char count. We're going to add whatever we have in the bytes. Again, this is not the number of characters because it's UTF-8. It's good enough. And if char count is greater than 80, and again, depending on what we have in the bytes in the slice, might be much greater or whatever, but it's good enough. We do a std_out, write all, so that is API. We do a B, and then we're going to give our new line. And we do a wait, because that is a Tokyo business, yeah? And then we obviously do not forget to reset our char count. Again, this one is a little bit silly, but it works. Here there's probably a trait we need to import. We can do this way. So that will kind of wrap it. And then we're going to write the output. And that will be this one, std_out, write all. And then we're going to do a std_out, flush to make sure that everything is flush. Press save, it compiles. Now I'm going to take this one. And the reason is because after my while, I'm going to do a println. Okay, so now what we can give to that is our Ollama client to generate the stream print. So we're going to take that, go back to our main, and now we're going to comment this one, and we are going to stream response generation. And that will be with this function, we'll give our llama and our gen rec that we just created above. Wait, question mark, print, press save. Now, because we had our cargo watch, that should run, it just did. And I can go back here to make sure that everything works fine. And then, boom, I have it. So that is pretty cool. And it's actually the end of our first chapter. So as we can see, the API is super simple and very nice to work with. And by the way, if you like this content and want to see more, like and subscribe, help a lot this channel. And also big thanks to my Patreon. You are making a big difference in my motivation to continue this journey for Rust educational content for production coding. Okay, let's get back to coding. So actually we're going to prep for our second chapter, and that is because we're going to use generation for our second chapter and we're going to stream is nicer, we're going to take this function, the gen stream print, and we're going to go back to our lib. And again, the point of the lib was to be able to make things that can be shared across examples. That will be a pub mod gen for generation, can be anything, doesn't matter. We're going to put our function over there. Then we're going to press save. We're going to use a super star, and then we're going to use the Ollama generation request, and that should be solved with use super. So press save. Everything works nicely. Then this one, stream, and then this guy. And that should be compile free. So that's nice. So that again is a submodule. Again, in production code, that would probably go to their own files and wouldn't even look like exactly like that. But that is a good function we can share now. And we go back to our main, and we're going to go here, command dot, import, press save, done. Now, there's going to be a lot of import here that are not needed. They are not showing because we have that. At the end, typically, I do a save, and then I clean stuff up. But right now, we're going to keep things like that, and then we clean later. So what I'm going to do now is just going to do a command C, command V, C02, context, press save. And then on this one, that I'm going to keep it. The single, I don't need it anymore. and I'm going to change the top. That is the way I do, because this way I can learn very fast. And it's a good trade-off between being somehow organized, such as in 6 months when I come back, I can find my duck, but relatively loose, such as I don't have to structure everything because I'm learning more than coding here. And by coding, I mean production coding. So for this chapter, we're going to use a context memory of a generation request. So to see how it works, the best way is we're going to make that as a prompt. So we're just going to have an array of static string. The first one is going to be why the sky is red, be concise. And then the second one is going to be what was my first question. And the reason why I want those to have nothing to do with programming, and in fact, the thing I've learned is if I give the system that we have, and it will think that the first question was about programming and not why the sky is red. So we're going to remove the system prompt just to learn about the context. And then after, we can do some tuning work here to understand why it doesn't work. And that could be another video. But at least we learn how we can keep some context in the queries. So now that we have this generation request, what is happening actually is when we do a gen request, the last one, so here we iterate through every generation response, but in fact, we have something like that where we can say if sum last data, we're going to have our res. So if we go to this one, we see that we have that type. It's final data. Then we obviously put the let here. So now we're going to get our final data, which is a generation request data. And that is what we're going to return. So we're going to actually, it's probably a better way of doing this. So we'll do print as well. And then we're going to return an OK of some of that data. Because right now we don't know if there's always going to be one or not. So we're still learning. So I'm going to do that. And this one will be OK none. So that would be this function. And so now obviously we need to have this type here, which I cannot copy like that. But if I go back here in our result, we need to have an option of generation final response. So if we press save, that should compile nicely. And then this one will return a result of an option of a general response. And within that, if we click here, we're going to see that we have this generation context. And that is kind of a vector. It's not a vector per se, but it's kind of data, I32 data, that will give whatever information to the model to remember a little bit of the conversation. So that is for the completion request. For the chat, we're going to see in the chapter 3, but this one has already some memory into it. So if we go back to the context now, so the first thing we're going to do is obviously put that in the prompt, because the whole point is to ask multiple questions. Again, that is not chat, just independent prompts that are with this kind of last context kind of thing. So that will go there, and we're going to do our final data. That will be our gen stream, the reference of Ollama, and then our generic weight, question mark. And so that will be our base. So we're going to remove this one, and that is a toString. And then this one, because we're on a for loop here, we can do toString or toOwn, doesn't really matter. That will solve this compile. Now what we're going to do is do a debug print over there, and that will be with our prompt. And then when we get our final data, what we want is to say if let sum final data, we're going to put the context inside the last context. So for that, so let's go down. What we're going to do is we're going to have our mute last context with our generation context. We're going to make this one mute. That will reformat a little bit. We're going to import that one. And then here, we're going to do the last ctx equal sum more final data context. So that every time it will run this one, and it will take the final data, the context, put it in the last context. And now what we need to do before we call the generate stream print, we need to say that if we have some last context from our last context, and on this one, we're going to take it. which is basically is going to set the last context to none, because we just want to take it once. And that will be our gen rec. And this is a builder pattern, so we give context and our last context. And so that basically will take it away from our last context. So that will be known after this one. And then we put it in the gen rec, execute the gen rec and print it. And then we take back what it comes back with and put it in last context. That's the way it works. And by the way, here I just noticed this one is a little bit a silly one here. We don't need to have the model up there. So we can just do this, and that will be our model. And we can do a toString here. So it wasn't needed to have it on top. It was just silly. Okay, so now we should be ready to run. So we're going to bring our terminal and we're going to do our famous cargo, watch, quiet, clean, execute, run, quiet, and C02 context. And I know what we're thinking here to say, well, are you typing that all the time? And everything is kind of a pain. And I don't, because actually I have a class in my shell, which allow me to do CWE, and then I give the 02 context. That will do the command I have. So you can make aliases to do that. So anyway, we do the prompt, we get our first answer here, why the sky is red, and then it gives that, and then we say, what was my first question, and it will say, why the sky is red. That is exactly what we had. Now let's test it here. And the way to test it is super simple. You go down, and we're going to not put the context back in the next gen request. We press save, why the sky is red, the sky is red, so. And then what was my first question? And then it just hallucinate. Yeah. So I don't know why it gives that, but it gives that. Now, if we had the system prompt inside the things, it will say that the first question somehow was about what was the best programming language. When we play with AI, we get this kind of fuzzy kind of response sometimes. And this is why it's good to have code like that, because we can play with it and see what works and what doesn't. So we're going to uncomment this one, press save, and then we're going to see that that works pretty nicely now. We are probably missing a new line. We're going to put it here because I'm lazy, but it should be probably in the print over there. So now it works a little bit better, it's cleaner. There's something wrong because I still have a new line here and not here. So there's a flush missing. If I go to the lib, I'm going to expand this one. And yes, so that is probably the reason. If we do one here, we should probably change the way here to do it. But again, that will work for now. And now I think it's more predictable. That's good. Okay. So we can go back to our context and we can just put one new line, and that should be pretty nice like that. Okay, much cleaner. Okay, so now that works fine. If we comment this one, then it will hallucinate like we've seen before. It's even getting worse, but doesn't matter. That is what AI is about. Not being a good salesman here, but it's still very cool. Okay, now one thing that I like to do often is I want to know the size of these things. And if you look at the context type, this is not public. There might be a way to know the size, but I'm not really sure. If we get the size of the struct, that will be the size of the struct, not of the heap. So tricky. But what I can do is when we do our last CTX like that, we can use a simple FS for that. And we're going to do save for debug, just for us. And we're going to have our context file path. And this will be C02-data and CTX JSON. Because it happened that this, if we look at the context, is serialized. So that's pretty smart that it does that, because sometimes we might want to serialize it somewhere or whatever. So I would like it to get the vector, but that is good enough. And what we're going to do now with that, so my best practice is I have the dot and then the C02 and dash data. So that is the way that I match the two. And the reason that I put dot is because in my git ignore, I always exclude all of my dots except git ignore, obviously. And that will allow me to then, if I have a dot something, it won't get committed and I don't have any error. And by the way, that template of getignore is part of the Rust10x VSCode extension. So I have the more and the mean. This is the mean. And if you want to see the more, that is the more. And I have all the fallback with the videos and the things and stuff. That is just because I'm just paranoid. But for the demo, that is plenty enough. So because I have that, then this will create a file, but won't get in the commit. And then we're going to use our simple FS, and it's going to be ensure file dir. So I give the file path. This is that file path, which can just be a string, and I can do question mark. And by the way, notice that we've put question mark everywhere like anyhow, and that's because of our boxed in business. And then we can have save JSON, and that is because in my cargo to ML in SimpleFS, I have full features, and that has a save JSON, save to ML, and even save binary files. We'll see it later, at least vector of numbers. So I'm going to do a save JSON. I'm going to give this one, and then last CTX. So as long as it's serializable, then it will be good. I could do a save JSON pretty as well, but this one will be enough for now. I'm going to import it, SimpleFS. Now I press save. That will generate the things, and that created my folder over there for CO2, and I can create here. And if I toggle the wrapping, this is about the size. So it's decent, it's very small. The question was small, so in a way it was good. I don't know if that includes the response, but at least we have an idea of the size. Okay. And again, the goal of this example here, of this XPs, is to really kind of learn very quickly the intricacies of the APIs, of the libraries, and the concept, and so on. So this is why I have this example, I have this data and these files, because it allows me to learn and have a good understanding of how things work. And then I put it in real code. Okay, so that we conclude our chapter 2. And now for our chapter 3, we are going to work on the chat API. So I'm going to stop the terminal. Typically, I even delete the files. It doesn't really matter. And then I'm going to create our chapter 3. And my question right now is, do I take everything here? I'm going to do that. I'm going to go brute force. There are 3 chat. And I'm going to close this. Again, I'm going to have a lot of kind of prompt over there. And I'm going to delete all of this because it's a different API. So it's not our generation API. Okay, so we're more or less back at square one. And since we're going to do our chat, we're going to go back with our instructions, just to make sure to have a real conversation now. So this one is going to be the one about what is the best language, be concise, and then that will be what is second best language, okay? So the way it works with chat is we're going to have a thread messages, which is going to be all our messages that are going to be part of the chat conversation. And that will be our chat message from Ollama RS. And at the beginning, we are going to put a vector, and it's going to be our system message. So this one, we're going to seed it with our prompt at the beginning. And for that, we're going to have a system message, and that will be our chat message, new, the message wall. So that again is from Ollama RS, and it will be our system. So that will be our instructions. And we're going to give our default toString. So what we have done here is we created our system message, which is in a way our first one, and then we're putting it in a vector. In this exercise, we're not going to do any pruning or worry about the token limit or whatever. We're just going to add the questions and then the answer to our vector of chat messages. And in fact, what we're going to do is we're going to add another question, which will be, what was my last question? And so that should return the second best language. So that will be a check that we're making sure that we're putting everything in the chat. So what we're going to do now, we will iterate. So we're going to get our prompt in prompts. We're going to do our debug print for prompt. Just do prompt on this one. And here we're going to at least give 1. Then we're going to create our prompt message. And that will be our chat message, new message role, user this time, and that will be our prompt to string. So that will create our new chat message. We're going to push it to the thread messages, push, prompt message. So far, so good. And then we're going to create our chat request. So that is the way it works, similar to the completion. We do a chat message request, new, our model to string, and our thread messages, and we need to clone because that will take the ownership of it. Make sure to import it, and that will return our chat message request, which we can run. So if we scroll down to our prompt, what we are going to do is let message content, and that will take a function that we're going to write, which is going to be run chat request. It will take our Ollama, reference of the Ollama client, and our chat request will be await, and that is the one that will do the heavy lifting. So we're just going to put the signature, run chat request, and that will take our Ollama client, and it will take our chat request, ownership of it. And we're going to say that what it will return an option of string. And that is because we're still learning the API. I think it will always return a result of string, but we're going to say result of option of string, and then we'll change it later. So just to be safe at the beginning. We're going to press save. That is going to reformat a little bit. We have the to-do, so we're going to implement it later, but basically that will return an option of string. So what we're going to do with that is if let sum, the content, message content. So here I say message content because it's a string and it's not a message. This is just personal preference. And then we do a let assistant message. So the way it works is that in our next prompt, we're going to get the prompt from the user here. And we want to also add the previous prompt, which is from the assistant. So the way we do it, set message, new, message, role, assistant, and then our content. And that will create our chat message. Then once we have that, we're going to add it to our thread message with just a push. I mean, honestly, Rust, once you do the things and you have the boxed in at the beginning, it gets very iterative and relatively simple. So we're going to press save, make sure that everything compiles. And now what we want is to implement this one, which is down there. So let's scroll there. So first, we're going to run the chat request. And the way it works is we do the Ollama and send chat request message, and we want the stream, and we give our chat request. And that will give us this kind of things again with a pin box, stream, and so on. And that will be a way to stream the response. So then we're going to get our Tokyo CD out to do the print. We're going to do our chip text wrapping. And then we're going to have our current assistant message elements. And that means that every time we get a message chunk, we're going to print it, but we're going to store it because now we need to rebuild the message because the last response doesn't have the message in this API. So we need to build it. So that's why we have this. And then we're going to do the while loop on our stream. We're going to get our response. So that is the same thing that we do before. We get our chat message response. We do our map air and just with a question mark. Then we'll do our code there. And after all, we're going to do the new line, the same thing that we had before. And if we're here, this means that we didn't get the final data. And so we're going to do OK, none for now. And again, when we're going to crystallize APIs, we'll make sure to do the right thing. So now we can focus on that part. And for that one, we're going to have two sections, which is the first one is if we have some message from our response message. And so that will be our chat message. And here is not the complete message, might be partial message that is streaming because we're using the streaming API. So we're going to get the content and then we're going to do our poor man's wrapping. So that will be this code. And then we're going to write it to the output with that code. So that will write it out. And then we do not forget to have our current, which one was a little bit too long, but we do a push and message content. because again, that won't be the whole message, so we need to build back the buffer in a way. And so that is the first one. And then, no matter what, after, we're going to do a if let sum, and that will be our final response. And I'm going to say why we put the underscore there. It's going to be our response, final data. The reason why we did the thing above is if we go there, we see that we have this data, which is basically matrix, but we do not have the chat message. So we're not really going to use this data, but what we're going to do is first do our little print, and again, that should be cleaned up eventually. And then we're going to have our assistant content, which is going to be our current assistant element. And since Rust something, we can do the join, and that will give us a string. And then we can return the OK sum assistant content. And if we press save, we should be all good. And then that's it. So this method is done and should be working, hopefully. So if we go back up to our prompt over there, so let's go and see the prompt actually. And now we can get our terminal. I'm going to do my cargo watch alias that I have. I'm going to put it in the GitHub or somewhere, and then would be a C03 chat. That hopefully should work. Prompt, what is the best language? Be concise. Rust is the best programming, which is true. COBOL. And then what was my last question? And that was about the second best language, which he gets right. And then that's it. So that will actually conclude our chapter 3. And that was pretty cool. There's a lot of things here that can be done to play with this and all of that. So when I learn again, I'm not trying to prompt and to have a nice prompt things and so on. If I don't need to, I just hardcode things and then loop through it and then check the result. And then I have my cargo watch if I need to change anything. And so, for example, if I want to make sure that it didn't get confused with a prompt, with a system prompt, I will say why the sky is red. And then I will press save, and then I will see if it works. The first one, it is right. The second one, okay, that was funny. Sometimes it says something else. But then the last one, which is the important one, he got it right, and he say, why is the sky red? Which actually corrected my English, which is pretty cool. And usually what I do a git commit at the end of each chapter or section, such as I can save them, and then I move to the next one. So the whole source code will be in the link in the description, and make sure to click on the link to get to the tag, because sometimes I update them, and so what is on main might be a little bit newer. So if you want to see the source code of this exercise, make sure to go to the appropriate tag. Okay, so I'm going to go back to this one. I'm going to stop the terminal, press save, and I'm going to do a commit on this one. And then we're going to go to chapter 4, which is going to be creating some embeddings. So for the embedding parts, what we need to have is some data. So what I like to do is I do underscore and mock data. And then within that, I created a file here, which is for embeddings. And then I just actually ask ChatGPT to give me 3 random text. Yeah, so we have one about the bees, one about quantum computing, and one about bread making somehow. So the goal of embeddings is to create a set of data that will mirror the text in a way, and will give us a semantic search to this content. So traditionally, full text search engine will do kind of a lexicon kind of search, which means, for example, rather to index bees, it will index B like this for this paragraph. And then if I search for B or bees, that will match. And for example, another one will be company, and companies will match because they are both indexed as company in a way. So that is another simplification, but that is what most of the full text search engine are doing. They are trying to be smart about how they cut the words, they trim it down, and then you do a full text, and then everything is indexed and so on. But the problem here is, let's say that we have another paragraph here where we're going to have, if I want to get poetic, I will say, every morning, my honey fly comes and wings me high. So obviously, the honey fly in a traditional full text search won't match But with embeddings, once we do the embeddings and the vector, it will capture the meaning of the things. And that might match. I'm not saying it's matching in the Mixtral or whatever, but that is a goal, is that now it will capture the meanings and say, well, honeyfly and bees are very similar in nature. And so the way we do the capturing of the embeddings is by splitting the text. So we cannot give the whole things and have a whole embeddings for everything. So usually you split it by 500 or 1,000 characters or whatever the different techniques. And then you create an embedding per segment, per chunk. And then you put it in a vector database. And then you search that. That gives you the segments. And then you can retrieve the text that you kept somewhere. So right now in this chapter, we're just going to do the embeddings to create the vector and see how it works. We're not going to be smart about how we split. And the way we split is very important, but right now we are going to be very, very dumb in the way we split because we just want to get something working, such as we can see how the embeddings API works. So we're going to split by 500 characters, and then that's it. And then eventually we will have other videos about how to do smart splitting. So for example, here we will probably split by a markdown kind of format. And then we'll make sure that all of these kind of things get splitted in the same set of chunks, such as if anything match, we can deduce that that was this paragraph, stuff like that. But right now, it's going to be very simple. We're going to do a dumb split. And then we're going to learn how to do the embeddings with the Ollama RS APIs. So this one is different enough that we're going to create it from scratch. So C04 and embeddings.rs. We're going to have our main async here, template, and we're not going to have that. So that usually is the best practice for the main, but in this case, we're going to use our XP Ollama result. So that is what we've been using. And then we know that we're going to use the Ollama RS Ollama. And then everything else will be mostly different. So the first one here that we're going to do is let Ollama default. And then we're going to create a couple of constants. And one will be for mock data dir, and then str, and that will be our mock data. So this way, if I want to change it, I can do it. And then one thing that I like to do is the same way that we have done for our second chapter. I'm going to have it here. And because I'm going to use it in multiple places, I'm going to have a const C04 dir str, and that will be our C04 data. And then that's it. And in fact, we can simplify this one as well. And then that's it. So we have our mock dir, and we have our C04 dir, which is the output dir. Okay, so now what we're going to use is something from the simple FS. And again, you can do it directly. And that is just a way to make sure that this directory exists. And again, because we have our box din error, we can do question mark. We're going to import, and then that's it. So we're making sure that when we're going to run that, that will get created as a folder. Then we're going to read the text from our file here, from the 4 embeddings. So for that, we can do read to string, and I can take it from the simple FS here. And the reason why is because, again, this is convenience, but if there's an error and the file cannot be found, it will tell me which file it is. Because otherwise, the default library says file not found, but you don't know which files, and every time you have to hunt back. And I don't like hunting. So that is a little convenient. Again, if you do a production app, you might do your own, obviously. So we'll do a mock dir, and we're going to join, and that could have been a constant as well for embeddings. Okay, and that needs to be imported, and that should work. And now what we need to do is we need to do the split, which will be the splits, and that will be our simple text splitter, and we'll give it a reference of text. And right now I'm just putting 500. I'm not saying those are good numbers. It's just to learn how to do the APIs, and then there's quite a bit of work to tune everything and making sure that we're doing the right split, the right size, the right dimension, and so on. But right now we're going to do the simple way. And I misspelled this one, and we're going to create right now. But again, that is a silly text splitter. We do not use it for vector search or even to test search because that will be super confusing. It's just to learn the API of the embeddings. So for this one, we're going to have our FN here, and that will be our simple text splitter. So we'll take our text, which is our str, the number of characters, U32, and then I do a vect, a string. Let's scroll down to it. Okay, so it's going to be quick and dirty. So first, we're going to have our states, which is going to be our vector. And then the last and the count, we're going to iterate through the char indices. And again, this is not full bulletproof. Some Unicodes and everything might get through, but that will be good enough for now. Then we increase the counter. And then once we match the num, we're just going to put it just a slice for now. And then we increment the states. And then at the very end, we're going to do the remaining characters that we're going to push it. So that will be actually a vector. Result will be a vector of string of str. So now what we can do is we can do a OK. And if we do a result into iter map, and that will be our string from, we can pass a function directly, and then we do a collect. And that should work. So there's many ways of doing the things. Here I make sure that I have reference of str. And in this case, I decided to return a vector string. We could return the reference of str because we have the str over there. So that will be the same lifetime. But for now, I'm going to do that. Okay, so now that we have our silly text splitter, so we're going to add this, and that will give us our vector of string. So what we want is that for every chunk, we want to create the embedding. And we're going to put it in the C04 data folder, such as we can see how it looks. So let's scroll down to main. So first, we're going to debug print our split counts, just for us, just to have the information about how many split do we have. Then we're going to iterate, we can take the ownership, and we're going to have enumerate because we want to have the index as well. We're going to use it for the file name, such as we're going to store everything cleanly in the chapter 4 directory. That's why we use enumerate and not just into iter. Then we're going to do the println, just to have a kind of a clean space. And then we're going to have our file name. And the goal here is to store everything in the folder, such as we can look at what we have created, the file size, and so on. Again, part of this exercise is not to save into a vector database. It's just to create the embeddings that then we can save in future episodes. We're going to see quadrant and everything. And then we're going to go back to our AI body and add all of those. It's going to be pretty cool. So on this one, the file name is going to be the format, and we're going to do a C04 embeddings, and we're going to format it a little bit. We're going to pad it with zeros to I always pad my numbers at least with 2-digit and txt. So this way, that will save the split into the file. That is the file name, and then our path is going to be path new C04 dir join file name. So that will create the path buff, and now we're just going to call fsWrite. So in this case, we don't have to have simple fs. This one is simple enough. And our segment, question mark, comma. So that will create the file of each split. So we need to import this one, and that is with a G, or a G. And in fact, if at this point we are doing our cargo watch, quiet, clear, run, quiet, example, and C04 embeddings. So again, I use usually my CWE, but I just want to show it sometime. And if we do that, it's going to do that. It's going to do all the empty line, but we're going to see all our files over there. So that is our splits that we have. We see that is a little bit silly here because it's just split at the middle of a word. But again, the point here is to learn the embeddings. That is going to be pretty cool. We can keep it running. We're going to stop it for now. but we already have something that's starting to work. So now let's go down to the for loop. So now we can print our debug here, just the text length. So when I do this learning, I like to print different things to understand. And then we're going to create our embeddings. Actually, we can call it embeddings, much cooler. And that will be Ollama. And we are just calling the function of Ollama, which is generate embeddings. The model name, so that will be our model toString. The prompt, that's not really the prompt, it's more the segment. And the option, none. And again, we're just learning. Eventually, we can look at what is in the option. Then we're going to do a wait, question mark, save. This one is not imported yet. And then that's it. That will compile. So if we had the cargo watch, we will kind of get this data. But now what we want is we want to save it there. And we're going to save it actually, because if we go there, this is text mode, and we're going to save it in JSON, and we're also going to save it in binary. Like this, we can compare the size and get an idea of the size. And software is all about order of magnitudes. So size matters when it's order of magnitudes apart. So that is what we want to learn right now, is to get a sense of the order of magnitudes. And actually, if I go there, this is a generate embeddings response. So that was result like that. Because now what we want to do is print the size of the embeddings. So embeddings in this case, so if we go to the type, this will be the embeddings, and then the embeddings is a vector of F64, which makes sense. And then it would be nice to save it, and we're going to save it in two different formats. The first one is going to be our JSON format, because it's a vector of F64, so that will be relatively simple. And so we're going to do a save JSON, and that comes from simple FS. So that is just a wrap on top of CRD.json and everything. You can use those directly. It's for my code here, experimental. I like my simple FS, but use whatever works for you. And then we give our path, we give our C04dir, join the file names that we just created here, and then we give our embeddings, our reference, question mark. So that will save this embedding into a JSON format. And then one thing that I was curious is to save it as a binary. So now we're going to save it as well, same prefix, same ID, and then we do a .bes, which is big endian. You can save it in little endian, it doesn't matter, but it does matter to specify which format you are choosing, and then the F64, and then .bin, and then we give the ID to make sure that it's padded there. And then we're creating our file path, so similar to above, and then we're going to do the save BE F64. So that comes again from our simple FS, and we can do save LE F64, and I have all of them. This is convenient again, you can save it by yourself. It's using the create byte orders and everything, so there's no magic there. And press save. This one was not imported somehow, and then that's it. So this two here is because in our cargo to ML, we have the full. So there is some multiple features, but that will give us all of these saves. And now that we have this in place, we should go back to our previous cargo and do this one, and that will override the files, but this time it will create the binary and the JSON. So if we extend it a little bit, we can see that we have all of those here. That's pretty cool. So now we can see that if we can go, we can stop the cargo watch, that will be kind of the size of the JSON. It's pretty big. And that is just for this little file here. So let me stop the wrap. So just for this content, we have all of this here. So it's pretty big. And the binary here, if we click, we don't have it. But what I usually do then, I can do a ls and a h and C04 data. And that will give me an idea of the size. So we can see that, for example, our text files is just 500 byte, which makes sense because that is what we did. And they're all 500 byte, probably except last one. That is an exception, not sure why. And then the JSON is 77 kilobyte and the binary is 32 kilobyte. And in fact, if you gzip this one, you will get to 33, 34. So that is what I did. So basically, the things to learn here is those files, which is a binary version of that, that is what you want to push to a vector database. But the trick here is that that is about 60 times bigger than the text version. And the goal is you push that to a vector database, then you do your vector search, it will give you those guys, and then you want to find back your ducks, because here we just have a file system here, but you will have that in a database, you will keep some IDs somehow, and then you want to point back to whatever embeddings you had, the text version. And in fact, you probably want to find the paragraph or the context here. So for example, an embedding could be just one part, and then we might decide that that was a part that it found, but in the prompt, we might decide to say, because it's part of this bigger part, we might give all of this to the prompt, for example. So this is why the splitting is very important. But in this video, what we have learned is the API to do the embeddings. And then we're going to do in future videos, see how we're going to do a better split, put them in a vector database, and so on and so on. And that will be it for this video. Hope you liked it. Like and subscribe helps a lot. Patreons is amazing. Until next one, happy coding.